Hi everyone, this video is on the mixed exercise 13, question 15. So we have this diagram, which is a sketch of the curve with equation y is equal to 12x to the power of a half minus x to the power of 3 over 2. So in part A, we want to find the derivative of y with respect to x. So to differentiate this equation, we just use the basic rule that we multiply the power by the coefficient and then the power reduces by 1. So we have 12 times a half, which is 6x, and then a half minus 1 is minus a half. And same thing here. So 3 over 2 times minus 1 is minus 3 over 2 x to the power of a half, because 3 over 2 minus 1 is a half. So we need to show that this is exactly equal to this form. So we need to factorize. We can take a factor of 3 over 2 x to the power of half. So we can sort of use what they have given us, even though it's very obvious. And then, yeah, so basically here inside is just going to be 4, because 4 times 3 is 12, divided by 2 is 6, which gives us exactly, the first term, which is 6x to the power minus a half. And then for the next term, we just have minus x, because x to the power of 1 times x to the power minus a half. It just becomes x to the power of a half. Okay, so this is shown, and that's the answer to part A. Right, part B is an interesting one. So it says at the point B on the curve, the tangent to the curve is parallel to the x-axis. So we have something like this, which is a tangent at B, and that's parallel to the x-axis. So we want to find the coordinates of the point B. Now, the first thing that might come to your mind when you hear tangent, it might be using the equation of the line, and by having that, maybe you can find the point of the intersection between the tangent and the curve, so that's going to give you the coordinates of B. But the problem is that we cannot use that method here because we don't have enough information. But what we can use here is a simple fact that B is simply the maximum of the curve. So in this case, now the way that we can realize why B is the maximum, it's not by looking at the curve, but it's from what they have told us. Because when it says that the tangent is parallel to the x-axis, we know that two parallel lines have the same gradient. And on the other hand, we should remember that the x-axis is just a horizontal line, and any line that is parallel to the x-axis, which is another horizontal line, has always the gradient 0. So because of that, we can conclude that the tangent here at B has gradient 0, and gradient 0 happens at the maximum or minimum. So by using that logic, we can realize that the gradient at B is 0, therefore B is the maximum. And in order to find the coordinates of B, we just need to find the maximum. So we have already found the derivative, and to find the maximum, we set the derivative equal to 0. And by solving this equation, we can get the coordinates of x, coordinates of B. So now we have 3 over 2. Maybe we can rewrite this as let's keep that in the same format. So for now, we have this is equal to 0. So the first thing is that we can just multiply both sides of the equation by 2 over 3, and we get rid of that. And then the next part is that we have 4 minus x, and then here also we have x to the power minus a half is equal to 0. And this can be simplified to 4 minus x is equal to 0, and x is simply equal to 4. So 4 is the x coordinates of point B, and then for the y coordinate, we just substitute 4 into this equation. So therefore, point B has coordinates 4 and 16. And that's the answer to part B. So part C, to two significant figures, we want to find the area of the final region bounded by the curve and the x-axis. Okay, so this part is very straightforward, because just integrating this equation is going to give us the area of this region that is bounded by the curve and the x-axis. And we just integrate this from 0 to 12. So those are the limits, and then the obviously we are integrating y, so it's 12x to the power of a half minus x to the power of 2 over 3 dx. Just to double check. Yeah. Okay, at this point, so the first term is going to be, so a half plus 1 is 3 over 2, so we divide 12 by 3 over 2, and then x to the power of 3 over 2. And then here minus, so 3 over 2 plus 1 is going to be 5 over 2, so we have 1 over 5 over 2, x to the power of 5 over 2, and the limits are 12 and 0. So now we can simplify. If we simplify, we get 8x to the power of 3 over 2 minus 2 over 5 x to the power of 5 over 2, and then we can substitute the limit. So we first substitute 12 and then minus 0 substituted. And to three significant figures, so first we substitute 12, and then yeah, because when we substitute 0 for the second part, that's just equal to 0. So to three significant figures, this is equal to 133.